Okay, so let's go ahead and download this entire thing. Right. So flag.h. Flag.h is the library that I use for parsing command line arguments. It's actually a very simple one. It is inspired by Go flag, I think, or this is just called Go flags. Yeah, so this is a Go flag. So essentially in Go flag, as you can see, you basically register new flags, and then you just say parts all of these flags, and it just gives you the flags. Does that make any fucking sense? I'm not sure. We can take a look at how it is implemented, right? So maybe we're gonna do a little bit of a Go programming, right? So this is a little bit of a Go programming. So import, what was that? FMT, and if I remember correctly, you also have to specify the package. Then fmt printf hello world, all right. So, and we're gonna do go build main.go, right? So this is something like that. So let's actually remember, so I think it's flag, right? And one of the packages that we'll probably have to use is a flag. There we go. So this is the flag. And so for instance, I want to have a n flag, all right, something like that. Help message for flag n, right? So it is an integer flag, right? The name of that flag is n, and this is the default value, and that's the description of that specific flag. So then after that, I have to say flag parse, right? So I'm parsing the flags, and then I can print the value of that flag. Int like n is equal to n flag. If I remember correctly, this specific value returns a pointer, right? And by the way, I can actually do it like that. So let's actually do something like go doc, right? And it is in fact a pointer. Look at that. It is in fact a pointer. So that means I'll have to dereference this entire thing. So if I do go run main.go, right? So go run n, there you go. So that's the actual value. But then as I run this entire thing, I can actually set n to 69, I believe. And as you can see, it set it to 69. So I don't remember. I think you can also print the help. So let me actually do help. And do you have something like help? So print defaults, that's one thing you can do. You can do print defaults. And they also have an interesting thing in here is that error help. So error help, and when error help is returned. So they are returned if help or .h flag is invoked, but such flag is, but no such flag is defined. What? Okay, so that's a little bit bizarre, but in any case, so we could probably define some sort of a flag like help. Yeah, there we go. So it automatically prints that. So if we want to add another flag like m flag, for instance, you just do it like that, right? So 69420, and then we can put m in here, and as you can see, so m is unused. Okay, so let's actually make it maybe something like this. Let's actually use this entire flag. Yeah, there we go. And now as you can see, this is the thing, and I can also specify both of the flags now, so which is kind of weird, right? So I have to put a new line in here. There we go. So that's a very simple command line library, which literally comes with Go. Right, it literally comes with Go, and I absolutely loved it. And I got inspired by this library a long time ago, so I created my version of this library in C, and it's called flag.h, right? So it's called flag.h, you can find it in here if you're interested. And so it works in a very similar fashion, actually. So we can create main.c, right, so, and I can include the usual stuff. stdio, I'm going to include flag.h, and I'm going to define flag implementation, right? So, and then we're going to do something like this. You probably have to provide int argc in char argv, right? So if you take a look at the implementation of this entire thing, you literally can do flag integer, I think. So we don't even have flag integer, but we have flag boolean, for instance, right? So you can define something like this. For instance, I want to define a help flag. So this is going to be help, and obviously its default value is going to be false, right? And here is going to be print this help message, right? And it returns you a pointer to the help, right? So it returns you the pointer to the help. So we can define a bunch of other things, right? Specifically in terms of integer, it's uint64, right? So it's basically I allowed you to to parse the biggest integer that is possible for C, right? So in here we can put n, and this one is going to be n, and the default value is going to be 0, and this is a value for n, and then another one is going to be m, value for m, right? So there you go. So, and then here after that you have to do flag parse, right? And as you parse it, you have to specify argc and argv, right? And if there is some sort of an error, it will actually return false. So you are obligated to actually print an error. So we'll have to do something like an error occur. But as far as I know, flag has print error, right? So it can actually print the error for you to the stream that you specify in here. I want to print it to the standard error. And on top of that, I like to print the options. First, I print the options, so the user knows like what kind of flags are available, and then I print the error. So, and in here, I return with non-zero exit code. So, and on top of that, if a help flag was provided, I like to just print the option, and exit with non-zero exit flag, right? So it's not an error. I just print the options. If everything is okay, we can just try to print the values of all of these things. So this is going to be n, right? So this is the n, and this is going to be m, right? If I try to compile the whole thing, main.c, right? So it compiled successfully. We can do main. There we go. The values of this thing is zeros. I can do help, and as you can see, it gives me the help, which explains how to use this entire stuff. It even has default values and stuff like it. It's very similar, right? So it is in fact very similar. Then I can do 69 and 420 and stuff like that. Right, so it is working. It is working. So one thing that I'm kind of missing in this library is that, as you can see, the library allocates the place for the value of the flag itself. Right, it defines where that specific thing is going to be located. In fact, internally, it just has an array of flags, flag structures. Right, so there's this thing called flag global context, and this is where it stores its state, because obviously, right, we call function, right, and it obviously modifies something in a global state. Where that global state is located? It is located in here. It's kind of hidden. It's a static library, and it's called flag global context. Right, and internally, what does it have? It has an array of flags with a limited capacity. It's not a dynamic array, unfortunately, because I developed this thing long time ago. So it's a static fixed array. But at some point, I think I'm going to actually make it a dynamic array. So though the capacity is kind of redefinable, at any point you can say, like, if 256 flags is not enough for you, which is kind of weird. Like, what kind of application has 256 flags? Maybe something like GCC. By the way, something like GCC or Clang may have hundreds upon hundreds of flags, right? But in our case, like, this library is designed for very small applications, or FFmpeg, right? So FFmpeg also may have a lot of flags. So yeah, maybe in the future, to tailor towards these kind of use cases, we can make it a dynamic array, but it doesn't really matter. So this is where all of that is located, and the actual location of where that the value is going to be stored is somewhere within the flag structure. We have a flag value which is tagged union, right? So here is the union, and are we back? Are we back? We should be back, actually. We're back, okay. Twitch just fucking disconnected me. It's just for whatever freaking reason, they just disconnected me. So yeah. Anyways, right. So sometimes I want to have like a global variable, and instead of like returning it like that, I want to kind of like register it, right? So I want to say flag var, and I'm gonna say, okay, use that variable to store the value of that flag. And as far as I know, Go has something similar. So it has variants like that. So we can take a look at that. Go doc flag. Right. So, and I think it's literally int var. Exactly. Right, exactly. So as you can see, it accepts a pointer to this entire thing. It does in fact accept a pointer to this entire thing. So we can take a look a little bit closer. So this is an int var. Right, so and it defines an int flag with a specified name, default value, and a usage string. The argument p points to an integer variable in which to store the value of the flag. Right, so, and I found that in some use cases, this is what I want to have. right? So it would be kind of nice to just like have this thing defined in here, right? And then I say, okay, register all of these variables, like that. So this is going to be something like this, and this is m, and that's it, right? So it's kind of also convenient, right? So not necessarily a global variable, right? Global variables, but maybe on a stack or something. Though it would be nicer to actually store them in a global, because yeah, so the context where you're going to store all of that is global context, right? So all of these pointers are going to be valid up until the end of the main. But honestly, after the end of the main, the whole application quits anyway, so nobody cares, I suppose, right? Right, so nobody really cares. But anyway, this is what I wanted to work on. Right, so introduce the so-called var variants of the flag functions, right? So which allow you to register your own variables. Sounds good? Sounds good, Tamaguchi. Let's fucking go. So let's take a look at what we have in here. So maybe we're gonna start with a single. I even have a to-do for that. Look at that. So this is something that I kind of anticipated. So flag boolean var, all right. So and that's basically the signature. So this is what we're gonna be working on. So there's some problems with flag name, and flag name is actually kind of a cool functionality. Let me demonstrate you. So essentially, let's go back to whatever we had in here, right? So because this is functionality that is not implemented at all, right? So and sometimes you want to know the name of a specific flag, right? So sometimes you want to know of the specific name of the specific flag, and this is how you can actually acquire it. So we do flag name help, right? So and it returns you a string, and it's the name of that specific flag. So I can do something like this. There we go. As you can see, it returned me help. So why it might be needed? Well, maybe I actually can change the name of that flag at some point. So then this particular thing also changes, right? So to reduce the amount of places I have to make modifications, right? So if I refactor in something, right, and I need to print something. For example, a deprecation message, a particular flag got deprecated. So in an error message, I want to say, instead of using that flag, use this flag, right? So, and because of that, I want to acquire the name of the flag so I can put that in an error message. So, and there could be some potential problems with that. So if we take a look at how exactly flag name works, right? So how exactly does it work? Right, so it goes, So essentially, we take a pointer, and we acquire a set within the flag structure, so we can get a pointer to the flag structure, and then we get the name of this entire thing. So it kind of depends on the fact that the pointer points to something within the flag structure, right? That's how it works. So essentially, the flag name actually needs this pointer to be pointed somewhere within the flag structure, so it can easily find the pointer to the beginning of the structure and then find name. So that's kind of the problem in here. So if we're going to be actually introducing custom places where to store all of that stuff, that pointer is not a pointer within the flag structure anymore. So we have to change the mechanism of how we acquire the names and stuff like that. So that's the main difficulty in here. But all of that is kind of hidden from the user, so I don't think it's going to affect the interface. I don't think it's going to affect the interface, so it's totally fine. Anyways, so I want to start very simple, right? So let's introduce the var variant for the Boolean specifically. So this one, it's not going to actually return anything, but it accepts the variable in here. So here's the Boolean variable definition and description. So maybe I'm going to actually put it nearby, right? So here is the regular Boolean variant, and this is the variable. So let's find flag bool. Where is this function implemented? Let's put the implementations away here, and here we are actually calling a variant of this function that works in a global context, right? So there's a variance of the functions that actually accept the pointer of the context, and by default they accept a global thing, but there's also a way to create a custom context as far as I know, right? So it's kind of interesting. So what if you want to have two different sets of flags, Right, so you want to have two different sets of flags. You can actually create a separate context, which is not a global context, and there's a variance of the functions that accept the first argument as the context. Right, so, and it accepts the opaque structure, by the way. It accepts opaque structure. Speaking of whether incore choosing opaque structures or not, it depends on the situation. So, anyways, what do we wanna do? What do we wanna do? So flag boolean var. Flag boolean var. So that means we also wanna have a variant which basically accepts the global context and the variable here as well, like this. So we need to have this variant of the function. All right, so let's actually find the Boolean thing. Right, so, and in here, there should be something like var. So that's the variant in here. And let's find flag C Boolean. Here it is, flag C Boolean. So the way this entire thing works is that we allocate a new flag, which is understandable, right? So we allocate the new flag, and this is something that we can do. Right, so we allocate a new flag, and then we set in the default value of the flag and the current value of the flag, and then we just return a pointer to this entire thing. We can also kind of do it like that, but we are the one, we are being supplied the pointer to the var, right? So we kind of inverted the whole situation in here. So we're being supplied the var, so I need to save that pointer somehow within the flag structure. So how can I even do that? So here is the, yeah, so the pointer is somewhere within the flag value. Right, and flag value is one of these things. It is one of these things. So what I'm thinking is that maybe we need to introduce something like flag pointer or flag reference. And it is basically the same things, right? Basically the same things, but pointers, right? So something like that, but pointers. Since we're only making Boolean work, let's actually remove the rest of the other types. We're only working with this kind of thing. And obviously, right, so we want to actually maybe put static assert in here in case the amount of types changes. We also want to modify the specific thing, but for now we only has a Boolean. So, and in here, we have the value, or we can have a reference like this. And there should be some sort of a Boolean flag indicating which one we're using currently. Maybe we're going to have something like Boolean. And how should I call this flag? So basically we need a special flag that discriminates whether we're using val or whether we're using reference. So I kind of want to call it ref, but ref is already kind of taken. So maybe use ref. Something like that. Like maybe the name of the specific flag doesn't really matter. But right now, it's the fact that flag is present and allows us to decide whether we want to use val or ref. So that will require modification of all of the places where we use val, right? Because in all of the places where we use val, now, depending on whether this thing is set to true or false, we have to maybe use reference. So that's what may happen. In any case, so let me actually go ahead and try to recompile the whole thing and go to the compilation errors. Maybe that is too early, right? So because now it shows a lot of errors that are not really relevant to what I want to do right now. So let's not put underscore here, and let's just try to compile whatever we right now have. So I have a little bit of a discrepancy between signatures, right? So I'm supposed to just have a void in here. And everything seems to be working. Okay, so let me actually find this function. So in here, here's the flag, right? And so what I have to have in here is just the default value has to be the default value that we provided. And now we have to use reference. We set the reference to true. And then I say, okay, reference as Boolean, right? So this is as Boolean, and I save that reference in here. So furthermore, in here, what I have to do is probably maybe use ref false. And that means I have to do that specific thing in all of the places where I allocate the new flag. Maybe one of the things to do in here would be when I'm allocating a new flag, okay, I'm setting it to 0, right? I'm setting the entire structure to 0. That means useRef is already false. It's already false. Can we check that pointer is not in the bounds of the array? Although a specific flag for this is clear design, I suppose. Yeah, I think it's better design like this, because it's kind of a hackish, right? So to just like check whether the pointer is between some boundaries. And for the people who's going to be reading that code in the future, it's just like they have to know that we're employing this hack, and it's like it will waste you know, a bunch of time for them. Yeah, I basically removing the const, but I don't remember why I do that. Right, so I don't quite remember why I do that. Anyways, so we have to do flag. I think it was boolean var, and maybe flag c boolean var. So here it is. So this one is just true. And that's about it, I suppose. That's about it. So if I try to compile the whole thing now, it is compilable. So that's pretty cool. So now we're ready to put underscore in here and break all of the places where val is used. So then we can go there. We can go there and basically check useRef and stuff like that. Okay, so let's actually see how many places it is broken. Okay, so when I do... That's exactly the place where I want you to do the thing. That's exactly the place where I want you to do the thing. So, yeah, this one is interesting. So how are we going to be doing all of that stuff? How are we going to be doing all of that stuff? We need to iterate all of the flags, right? So I'm going to be iterating all of the flags. And, ooh, this one is interesting because... it kind of assumes no context, right? So it kind of assumes no context, but we also have this flag C name. Yeah, oh my god, I remember that. So since we're just using like offset within the structure, right? So we don't really need the global context, right? But I created the variant for the context anyway, because right now internally there's no difference between flag name and flag C name, which accepts the context. But we are separating them on the API level in case something changes, especially if we are to implement the var function variants. Yeah, I remember that. This is actually kind of funny. So that means what we want to do in here is actually call the internal thing in here, right? So I want to return it like that. Then I want to take the flag global context and I pass it in here and I just like put a value in here. And then this particular code is going to be employed in this variant of function, right? It's going to be employed in this variant of function, but only under a certain condition. So here's the context, and the way we do that, first I need to get the context itself, right? So how do I usually call the variable? If I want to save the context somewhere, how do I save the variable? How do I call it? I don't even call it anywhere. Oh yeah, so I usually call it FC. Okay, so I don't remember what was the convention, but yeah, this is how I do that. So it is opaque, as you can see, and it's just like void star. So FC. So in here, what I want to do, I want to actually iterate all of the flags that we have in FC. So, so flag context, and flags count plus sign. Okay, so within this entire thing, it's a flags I, and within that stuff we're looking specifically for things that use ref. Right, if this specific flag uses ref, we are looking at the ref of this thing. And now we need to take the pointer, but the ref in here doesn't have a pointer. Right, so because it's a union, and I'm starting to think that maybe fuck that. What if I just say that flag ref is actually void star, and simply depending on the flag type that I have in here, I'm going to be casting it to different pointers. I think that's much better, and it will allow me to literally just compare two void stars if I go here. So if that specific ref is equal to this thing, we know that you're trying to get the name of the custom pointer, so we can just return you the name. We just return you the name. So that's how it's gonna work. Then if you fell through, we can employ the previous way of doing things. We casting it to a char, finding offset within the flag, and we're doing the usual thing. Or like, this is a little bit unsafe in a sense that what if you provided like arbitrary pointer in here? So a safer way would be probably do something like this. If value, right, so this is the value, and we take a pointer to it, and if it's equal to that specific value, that means we found this thing, so we return the name. And yeah, this is kind of like similar to, it's not exactly that, right? So because it's offset of flag value, no, it's correct actually. It's actually correct. All right. So so this particular part should be unreachable. So now we can clearly say that this thing is unreachable. So that's much better, I believe, right? So that's much better. And we can actually remove all of that stuff and blah, 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 blah. But here's the interesting thing. There is a little bit of a duplicate code in here. There's a little bit of duplicate code. How can we compress this code? Does anybody know? We could, okay, so do something like this and this. So that's the first condition. And here is the second condition. And we can sort of concatenate these two conditions with or. So it's either that or that. Is that good? I'm actually not sure, like, which of these two is more readable? This, I think both of them are shit. Like, it's a very difficult choice. Like, both of them read like shit, and I think I suspect why both of them read like shit is because it's very hairy. Like, there's a lot of repetition of this specific expression. Yeah, so both of them are hard to read. So one of the things I'm thinking about is just like factor out the flag to something like this, right? So then I can easily replace all of this stuff in here, right, that with flag. So that's already by itself, regardless of which one we pick, easier to read. So this one by itself is already easier to read. And because of that, I think if we just compress it a little bit more like that, it's even better like this, right? So maybe not, kind of difficult to tell, right? So if it's a useref, just try to do that, right? Otherwise, just compare it. Yeah, so I think this one is a little bit better as soon as you compress this entire thing. It can concatenate the two ifs and do else if without the extra. Yeah, so maybe something like that. Okay, so I think that's the final thing I want to go with. So that's the name we're dealing with. All right, next one. So, and if I go to put underscore in here. So the next problem in here, so this is creating the boolean, right? So that's definitely one value, and then we return the boolean. And yeah, so this is the ref. What you don't like, so since I changed this ref to just void star, I can do things like that. Right, and since there is implicit conversion between just a regular pointer and void, I don't have to even cast anything or anything like that. So it's kind of interesting. The more I program in C, the more I find that this implicit conversion of any pointer to void star and from void star to any pointer is actually insanely convenient. It is actually insanely convenient. So even though C++ freaks out when you try to do something like that, right? So it always requires you to explicitly do the cast. Just conversion of any pointer to void and void to any pointer kind of makes sense. And it doesn't leave that much room for a mistake. It's not like you're reinterpreting one type to another type. You kind of are, but not really, right? So it's just like you... if you use OOP terminology, right? If you use OOP terminology, you're just upcasting that pointer. So you're just casting it to a parent class, and that's kind of fine, isn't it? Right. So because void star is a broader class of pointers that int. So the only problem here is downcasting, right? So maybe C should have actually required you to specify the type when you downcasting the pointer, but upcasting the pointer to void kind of makes sense, right? And it should be implicitly happening, right? So C++ allows the first, but not the second. Really? I think it just doesn't allow any of them. Wait a second. So we have to check that. All right, so just a second. Okay. So if I have something like a point to 69y, right? So and then I say void star n, and I just do x, right? So I want to try both of them, right? So, well, I mean, I have to do main cpp, right? So it doesn't allow you. Okay, so so it. Okay, so in fact, C++ does treat it like upcasting. Okay, so it does in fact treat it as upcasting. So, and then, right, so, well, okay, so maybe that's exactly how we should do that. Good job, C++, I guess. So, and this one does not allow that because it's downcasting. All right, cool. I guess I learned something, thank you. Okay, so... yeah, that makes sense because it's kind of consistent with the behavior of C++ where you can take a pointer to the child class and just like assign it to a parent class, right? So it's kind of consistent with that. All right. Raise C++ win. Yeah, I suppose. I kind of agree with that take. Honestly, I kind of agree with the take, right? So you kind of be, if you're downcasting something from a broader class of types to a narrower class of types, you kind of have to explicitly tell that. You have to be explicitly aware. But the other way around, like it only gets annoying. So what's the biggest benefit for you when using C++ over C? I guess the like array AI is one of the benefits of C++. Namespaces is another benefit of C++. Slightly stronger types checking. Apart from that, templates sometimes are useful. Yeah, templates sometimes are useful. So you can finally naturally implement min and max function. So as you guys know, implementing like a generic min and max function is an unsolved computer science problem in C. Right, so you can use macros, but then you will always have to use some sort of a compiler vendor specific extension to actually properly implement min and max. And C++ they actually implement it naturally, right? So you can just do something like type name t, and so here is your min t a t b, and so then if maybe you can do something like a less than b, return a, otherwise. And that automatically works for any kind of type. So as far as I know, in the modern C++, you can even try to do something like auto. Is that something that you can do in the modern C++? I haven't programmed in the modern C++ for a while. Will something like this work in the modern C++ without templates or anything like that? Right, I think that's a thing that you can do. Yeah, this works, okay. So I haven't programmed in that C++. So my first ever job was a C++ developer, but it was around the time when C++ 11 only came out, right? So it was around in 2013, 2014. So C++ 11 only came out. It wasn't fully adapted yet. So on that job, we primarily used C++ 03, the previous standard, right? And we were slowly adapting C++ 11. So that's my first ever job. And then I think around 2017, another professional C++ job that I had, right? So, yeah, not that much of the like a modern C++ experience. Each auto adds a template parameter. Oh, okay, so that's how it internally works, right? So not on, but does it work only internally like that, or there's also semantic similarity between these things or differences? I don't quite know. So as far as I know, they also introduced like a new syntax for functions, right? So which makes it look like sort of like, what is it? Rust. So When did you start streaming? I think my first ever stream was in 2015, and it was actually training return times. Yeah, so I kind of vaguely remember something like this. My first ever stream was in 2015 on YouTube in Russian. So that's like, so basically 10 years. I'm streaming 10 years already. For quite some time. Thank you so much for the subs, by the way. Thank you so much for the sub. So I have a lot of experience in streaming, as you can tell. Anyways, so let's actually continue. Yeah. So this one, thank you. So this one. All right. So what we have? I want to recompile the stuff. Where is my? Yeah. So yeah, let's freaking go. So this one, yeah, now I have to go through all of these places, and put this extra underscore. But I feel like I still have to do that. All right, so because I don't want to miss any place, because any place is kind of important in here. So this is just a value, this is just a value. Okay. All right, so this is what I'm talking about. So this is parsing, right? So this is parsing, and this is where we have to do the change, right? By the way, recently I introduced the ignore syntax. Like literally today, I actually added the ignore syntax to the flags finally, right? So if you want to know what it is, so let me actually stash all of the changes we made, and let me recompile all of the examples and stuff like that. So here is the example C. Right, so, and there is a bunch of flags in here that you can set. So here is the documentation for this flag, for these flags. So let's actually try to set Boolean, right? So we set in Boolean to that. So then we can set the size to 69, and then we can set str to hello. Right, so the ignore syntax, I already explained that in one of the previous streams, is that you can comment out a particular flag. You can put a / in front of this flag, and basically it will still parse it. It will check everything properly, but it will treat it like you never provided it, right? So that's basically what's going on. So I can also like comment out size 69, and as you can see, it's not 69 anymore. And then at any point I can say, okay, use this flag again, and it's 69 again. So it's ignore the flag. So, and the whole point is that quite often you rerun the same command over and over again with different flags, and some flags may be kind of big, right? So, and deleting and adding this entire flag is kind of tedious. I want to be able to flip-flop between this flag. Okay, so I want to have hello, then I can disable it, then enable, disable, enable, disable. And when you work in the terminal, you always press up and enter, and it's just like a little bit more like frictionless, right? So you know what I'm talking about? So this is what I added to my library. I think, as far as I'm aware, this is the only command line parsing library that actually implements this kind of syntax, right? So, and the first one. So yeah, and it's rather convenient, right? So I actually battle tested it with my applications, and it is in fact convenient. Quite often I can have like a really big command line, and I want to disable a specific flag, but then I want to re-enable it, and it's just like, okay, I'm gonna just mark it and ignore it. Right, so, and then on the next run, I'm just going to enable it again and stuff like that. And I feel like in terms of like bash, it is actually super convenient, right? So if you're running this kind of stuff in a bash, bin sh, example C, and I can do str hello, then size 69, right, so, and let's actually maybe mark this entire thing as executable, and I just want to do run sh, and as you can see, it is working. Quite often, one of the things people do is that they put each and individual flag into a separate line. Let's actually quickly do that. And then at some point, one of the things very often I want to do, I want to comment it out, and as far as I know, you literally can't do that. Does anybody know a really good way in bash, in its syntax, to say, okay, comment out this specific flag, I don't want this flag? Because I haven't figured out how to do that in a convenient way. Because this particular, like, it's not convenient. I wanted something to flip-flop. But with this syntax, I'm finally able to do that. Like, I literally like fixed the flaw of the bash syntax with this one. Honestly, this is actually kind of cool. I think it's not possible. Now it is. Now it is, right? So this library allows you to actually do that. This library fixes the flow of bash. So yeah. Damn, this is so cool actually. I usually comment it out, then move it to the bottom of the... Exactly. There should be a mechanism like that. Time to write to Stallman. Stallman doesn't do any programming anymore, I think. I think he doesn't do any programming anymore. He's just running around, eating his feet and advocating for things. That's what he does these days. Anyways, so yeah, let's continue. So we need to recompile the stuff. Stallman can't even install Linux, exactly. How, after that, he's calling himself a computer hacker? Join us now and share the software. You'll be free hackers. You're not even a hacker anymore. So who are you trying to liberate with this one? I understand. Anyways, so yeah, let's just try to compile this entire stuff. Where is the make? Not really make, but GCC. Okay. What the fuck is going on with me today, chat? Yeah, there we go. This one. Okay, that's cool. So it works, but it's not supposed to. I know why why it works, because I have to unstash some changes. So I haven't finished yet. Now we're talking. Okay, so essentially, here's the ignore syntax. Right. So already explained what this. Thank you for the rate toggle bit. Thank you. So maybe I'm gonna just like subscribers off. Right. So there we go. Hello. Now. So what I want to do, essentially, instead of using val, if fc flags is userf, what we have to do is we have to take flags I ref and cast this entire thing to the pointer to the value that we're saving. In our case, it's a flag list, right? So this is a flag list. We casting it to the pointer to the flag list, and then we're just appending things. So list append. Okay, so this one is really weird. What are we? Why does it accept a type? I'm not quite sure why does it accept a type. That's because of the fucking C++. Okay. But I already agreed with C++ take on this one, so I can't complain. So, anyways, that's fine. Fine, chat, everything's fine. I can live with that. People really misunderstand me complaining, right? So, if I complain, it doesn't mean that I can't do that. When I'm complaining, I'm just making the developer noises, right? So... You know, when the car is going, right, so is moving, right, forgot the word. When the car is moving, the engine is making noises. The engine is roaring. When I program and I complain, that's just a programmer noise, right? So that means I'm moving, right? Just because the engine is roaring, it doesn't mean that it's broken. It's moving. The same with the developer. I'm complaining. That means I'm moving. I'm developer. Right. So do not misinterpret that. Do not misinterpret that. Yes. The noise is just all right. So yeah, that's basically the difference. And now we have to do that for each and individual branch, and it's excruciating. Brevsky, that's excruciating. So we probably there's going to be a lot of duplicate codes, so we'll have to factor it out somehow. How come you're streaming so early? Because I want to. Because I'm a person with a free will. Like majority of people in the chat, I just do things that I want. All right, so we have to repeat that shit here as well. When do you sleep? When your mom is home. Excuse me. So if ignore like that, there we go. Let's fucking go. So I think it's literally the same. It's literally the same code because we're using this thing, right? We're using this thing. It's just like the only difference is the type. So, and that type is mute, and this one is mute. Okay, let's go. What else do we have in here? So it complains about some of the things in here. So that means I just use this stuff incorrectly. Yeah, I think I know what is going on. So this is this thing. All right. So yeah. So now we have this kind of stuff. Ooh. Yeah, this one is annoying. Yeah, this one is annoying. Chat. Look. We have a support for flag equals syntax. Right. So if you take a look at some of the examples, you can do something like size 69, right? There you go, that works. But on top of that, you can also put equals between the flag and the value, and that will also work. So accidentally, it also works for the Boolean flags, right? As you can see, here is the Boolean, and it's set to true. And then you can put equals in here, and it still count as setting it to true, but then you can provide any value in here. Yeah, so I don't know, right? So this is what this to do is about. So when the equal syntax is used, the Boolean should be probably parse values such as true, false, on, off, etc. But I'm not sure how backward compatible it is to introduce such syntax at this point. So 69 does not, yeah, probably 69 also does nothing, right? So because literally we just ignore everything after equals. Like, I think this is an oversight of mine, right? So I should have actually implemented it properly as soon as possible. So I'm not sure if it's backward compatible to even introduce something like that. But honestly, on top of that, I feel like introducing these specific words, especially on, is kind of dangerous because I don't want to repeat the YAML mistake, the $1 billion YAML mistake. You guys know what I'm talking about? Yeah, YAML. I think YAML mistake is specifically no, right? So yeah. So it's so goddamn fucking stupid. It's just like it is not. It's even like I would say it's a rookie mistake. It's a format, such a widespread format with an insane rookie mistake. But maybe this is because it's old already, right? So maybe at the time, like we as a community of developers were not that experienced in this kind of stuff, and we kind of needed to burn ourselves this way to actually become smarter, right? So if we were developing something like YAML today, we definitely would have not made that mistake. Just don't support Norway. Sorry, Norway. Yeah, just rename Norway. Yeah. Okay. Nice one. Anyways. Okay, so what we're doing, so we're using le référence. So this is le référence. And essentially, we don't have to do any append in here anymore. So what we can do is just something like this. And in both of the cases, we just set true. So this is a reference, and we're actually setting this to Boolean and dereferring this entire thing, right? So that's what we do. And then here's the value as Boolean, right? So this is as Boolean, and we're setting it like that. So there will be a lot of duplicate like this. And I feel like this entire thing could be actually factored out to a nice function. Somehow, not really sure how, but yeah. Yeah, I'm really not sure how it could be factored out. So maybe as a pointer, but then yeah, it's kind of annoying. But anyway, so yeah, so that's the thing we're doing here. Right, so let's try to rebuild the whole thing. So there's 3 places left where we have to repeat the whole thing. So, and maybe, by the way, I can actually copy paste lots of stuff in here. And yeah, that's a mistake. If not ignored, we have to put this thing in here. Flag.h library is from 2021. Yeah, so I developed it a long time ago, actually. It's a very old library. Yeah, so 4 years ago, from 2021. Yeah, so... People don't realize how OG of a streamer I am and how much shit I already developed. It's actually kind of insane, especially people who discovered me relatively recently. I have almost 20 years of experience, if you think about it. So I started the program in 2006, right? So yeah, almost. So it's 2025, right? So the next year is going to be 20 years of programming. So you're not just the funny Twitter guy. Yeah, I know. Insane. Some of your stuff is insanely useful, maybe. Well, some of my stuff is insanely useful for me personally, and that's what's important, I believe. So essentially, like, if you want to make something useful, the easiest low-hanging fruit is to make something useful for yourself, right? So because then you'll have at least one user. When you're making things and don't dog food them, like, you have no direction to move. Looking at UC3, by the way. So yeah, I think it's kind of important to just like make things for yourself, at least. Make things for yourself. And sometimes it is actually kind of cool to make the things like almost exclusively for yourself, by the way. Almost exclusively, and never expand your user base and only things for yourself. For example, I have an immense pleasure using Markut. So this is like an editing language, editing software for my VODs, and the only user is me, and I literally do not expect anybody else to use it. Because of that, I break backward compatibility all the freaking time, and it's so fucking refreshing. I don't have to think about anyone else. I'm the only one who needs this piece of software. It is so fucking cool, right? It's just like I can add construction to the language. I can fucking remove construction from the language. Nobody gives a shit because I'm the only one who's using it. It's so fucking cool. I love it. So so why even keep old version more? Exactly. Honestly, like, backward compatibility is an insane pain in the ass, and I don't want to be in a place of people who were doing the migration from Python 2 to Python 3. Like, I mean, don't want to be the Python developer, right? So, and going through that fucking catastrophe, which is Python 2, Python 3, which is still going on, by the way. People think that Python 2 died. No. There are still places in the world, I guarantee you, there are still places in the world where people use Python 2 because it's too much of a hassle to actually migrate to anything else. I heard they use PyPy specifically for that because I think PyPy is the only Python implementation that kind of supports Python 2. Who on earth is using Python 2? Probably some old legacy scripts. Some old, like, huge ass old legacy scripts, and it's too much effort to rewrite them. Places like governmental organization. Well, I mean, like, we ourselves, when we were implementing the WebSockets, encountered such thing, which is Autobahn test suite. Autobahn test suite. So it's a test suite, and it's written in Python 2, and they do not plan to rewrite it because it's too much fucking effort. So yeah, and the only reliable way to run this entire thing is in a Docker container, right? So because it's just like nobody properly supports Python 2. Like, incidentally, on my machine, I do have Python 2, but it's a complete accident, right? So here's the Python 2. It's just that for some reason Void still supports Python 2. I don't really know why, but yeah, it kind of still works in here. I saw a video by a meta engineer who said it was a pain in the ass to migrate from Python 2 to 3. People wanted her dead. Yeah, that's so, and this is probably one of the reasons why Jonathan Blow is like hesitant to release Jai, because as of right now he literally can break things very easily, because there is, like, I think right now there's 1,000 people in beta. So, and all of the 1,000 people know what they subscribe for. So at any point he can just like remove a construction that a lot of people are using, and that's expected. That's totally normal. At Handrich, okay, so it's very close to 1,000. So, and all of them know that their code at any moment can stop working. So like in that environment, it's very easy to experiment with the language. It's very easy to experiment with the language. The casting syntax war continue regardless. Yeah, I've seen it. So, which is kind of interesting. Yeah, so when you are making a language and you're trying to be first to market, you essentially lock in yourself into whatever mistake you make early on, and you're gonna be living with these mistakes for the rest of the language existence, right? Okay. Harder to find bad ideas without a lot of users as well, though. Well, I mean, almost 1,000 of users, I guess, is enough to kind of like battle test this entire thing. And people are writing pretty big projects in like in Jai as of right now, even sometimes commercial projects. And I personally seen a couple of startups using Jai. So the only reason, by the way, I'm aware of these startups is because they literally approached me, right? So, right, several of them. It's actually kind of weird that it happens more than one time. Just saying. Just saying. So yeah, people actually use Jai in prod, right? So people like to joke that Jai is not existing fake. People use it in prod. Whoever is in beta, people already using it in prod, right? So it's kind of closed, and I understand the resentment of people who are not in beta, but it's a real language that is used in prod already. So 1,000 users sentient enough to send an email are much better than billions of users that can't even open a GitHub issue. Exactly. I think it's a pretty good strat that John employed, right? So just like limit the scope of the issues that are reported. Okay, so let's actually continue with the rest of the stuff. Ignored. So, all right. So this has to be. Why do you, like this is a pure reflex, right? So to put else in here. So this is going to be underscore, and yeah. Maybe I have to do this kind of thing. I probably should also extract this into a separate like alias or something like that to make it less annoying for myself. So this one is a character, so this becomes true, so this becomes arg. Otherwise, this becomes this. Okay, that is very cool. That is very cool. All right, so we have only two things left. By the way, I recently rediscovered that I implemented something freaking genius for this library. And it's also kind of stupid. I think I should have not done that. But if you have a flag that is type of size, right? So look at that. I set size 69, but then I can say 69K, and it multiplies it by 1024. So I can put M, so it's a mega, 69 megabytes or something like that, and I can also put G, and it multiplies it even further. So, and I think I made a mistake, because I think this should be multiplied by thousands, right? And if we want it to have kibi, it should be more like key or something, or small one. So I think I kind of made a mistake, and I'm not sure I will be able to fix that in a backward compatible way. Right. So what if I put k without any number? It's just 0. So, and if I put something else, it says invalid size suffix, right? So I can put e. Yeah, so invalid size suffix. That's what it is. And 69e doesn't work, but 69k does in fact work. I completely forgot about that, by the way. Yeah, 2.0. Yeah, I feel like at some point we'll have to do flag.h 2.0, because quite a lot of sort of problems accumulated within the library that I really want to resolve. Right, so, and it's definitely going to be 2.0 at some point. So when we're going to be painful migration from flag 1 to flag 2, right? And everybody's going to be hating me. Or not, because who uses this library? I don't know. Well, I know at least one another person who uses that library. So yeah, maybe this is going to be how it is. So it's going to be a separate file. Like, honestly, in any of my existing libraries, I still haven't done a major release because I'm a pussy. I'm scared to do that. Yeah, I'm going to admit that. I'm really scared of that. And I have no idea how to even approach that. One idea that I have is literally have two files in a repo, right? I do major release, and I literally fork the library. Now there's a version 1 and version 2, and they're backward incompatible. And I was thinking is that maybe when I implement some features, and some features may actually exist in both of the versions of the library, I'm going to be releasing both of them. Two branches, basically like I fork them. So, and essentially, imagine I have two libraries, and the version is 1.4 like 0. And then after that, I need to make a major release, and I have something like 2.0.0, right? And then I realize that I've got a cool feature, but then there's a lot of users of the previous version. So I simultaneously release version 1.6 and 2.1. And both of them contain this new feature that can be accommodated in both of this version. You can do like SDL as SDL branching. I don't know what exactly SDL does. So they have something similar as well, right? So they kind of have similar approach. So my idea is literally, if you do major release, just maintain two versions. So is that a good idea? I think it could be. Double the workload. Yeah, that's one downside. They keep updating SDL2 and SDL3. So they actually go in that route. Okay, so that's interesting. That sounds like a pain in the ass. Well, I mean, that's a law of pain in the ass conservation, right? So you either pass this pain in the ass to your users, or you endure it yourself. The amount of pain in the ass doesn't change, right? So it's just like you have to decide. So, you know what I'm saying? So yeah, it's just like a pain in the ass conservation. So yeah, I think that's the one way to go about it, honestly. That's the one way to go. It's just like keep maintaining this kind of stuff, because some projects might be so deeply entrenched into this older version that it's impossible or infeasible to rewrite them to a newer version, but they may need a feature that is in a newer version, which is also easily backportable to the older version. Why not backport it? At work, we can maintain up to 4 releases. This is a cherry pick hell. I see. But cherry pick implies that you're doing something with version control, right? Here, by the way, I propose to use the same repo and the same single branch that goes forward. Is just in a repo, you literally have two files, which is flag1.h and flag2. And within a single commit, you update two files simultaneously. No cherry picking, no anything. You just literally maintain it like a single project. Two versions like a single project moving forward. So that's the idea I have, actually. Look at this thing. Flag.com. Yeah, oh my god. Yeah, so you're starting to also have like a common parts of this thing. Yeah. So I think what we're missing is between breaking changes, there will be different end user APIs. Yeah, I guess. So it's more like we're doing versions for web APIs. Yeah, so in web, people maintain both versions of the API. Will you stop support the previous one someday? Maybe. Maybe I do. Maybe I will. But I haven't done a measure release yet anywhere, so I don't really know how to approach that. Maybe I should do that. And I think flag is a good library to test my ideas for breaking changes release, because it's not as widely used as knob, for instance, right? I'm really afraid to touch knob, right? So to just change something that breaks things, right? It's not that widely used as knob, and it already accumulated enough problems that I really want to fix in a backward incompatible way. So that might be like one place where I'm gonna do, where I'm gonna test all these ideas. But anyways, so just do like Microsoft and never break anything ever for 20 years. But then your entire library turns into abomination, which is Windows. Right. So, but anyways, yeah. But at the same time, right, it's kind of easy for Microsoft to never break anything for 20 years because they have functionality that very important clients depend on. So essentially, those very important clients can just drop loads of money on them to maintain that functionality. I'm talking about big corporations and governments. Not a single government or big corporation sponsoring Knob. So I don't have resources to do that, so I'm sorry. Any big government wants to drop money on me so to support Knob for 20 years, I'm down to do that. Anyways. Still keep doing that, by the way. Still keep doing it. All right, so use ref. Okay, so if we're using le ref, what we're doing essentially is something like this. We need to finish that chat. We need to finish all of this shit. So this is going to be ref, and I'm taking a pointer to 64. We're almost done, I think. As soon as we just like do that, it's going to be a working feature. Not only working, but maybe even potentially twerking. You never know. All right, so this is that, and might as well ignore. Okay, so we got that. So this is a as size, and as far as I know, it literally uses size t, right? So if I do as size, yeah, it is in fact literally size t. So size t, and it as size. All right, that is very cool. So, and I suppose this is just that. Pretty cool. Let me see. Can we have some examples now? So, yeah, Boolean help, and I'm gonna do uint64nm. So instead of all of that stuff, we're going to do var variant. So this is help, and this is gonna be pointer n, and this is m, and all of them are var variants of these things. If I try to compile that, something got fucky bucket. Get fucky bucket. Oh, okay. So we only implemented that for booleans. Okay, I see. All right, so let's test that for booleans then. So something like that. So without any var variant, we'll have to introduce them, by the way. They're just fucking neighbors. Fuck you, neighbors. You can't even speak English, motherfucker. You don't even understand what I'm saying. Motherfucker, don't even understand what I'm saying. Fuck you. Alright, so imagine if my neighbors actually speak English, right? It's gonna be awkward. It's gonna be fucking awkward, but yeah, anyway. So naming, by the way, works. Look at that. Look at that. So naming actually works, and this is really cool. Then I can change that to just a Boolean variant, right? So this is just a Boolean variant like that without any var, and naming, oh, something fucked up, because why? I just run it without anything particularly special. This is because now this is a pointer, right? One of the reasons to use C++. Unreachable. Okay, so speaking of like why you want to use C++, in C++ this kind of shit would never happen because it's just a stricter types. Right, so we have a pointer. You can use a pointer in the context of condition, and I think in C++, yeah, in C++ it also wouldn't be error, fuck. But at least here it would be error, I think, when I have to pass a pointer and it's just like not a pointer. So yeah, but anyway, so flag name works, right? So we pick in the right name correctly, right? So all of my concerns are actually addressed in here, so which is super nice. I'm super happy about that. We need to introduce the rest of the variants. So we need to introduce flag uint64 and so on and so forth, right? So this is the rest of the features that we need to do. So this has to be flag var, and it's going to accept this thing as a variable, right? So this is that variant. We also have to introduce flag size. This one is going to be void, and that is in fact var. All right. And this is a var variant. Can we maybe align all of these mother flippers somehow? I really want to align them. So if I do align flag, I kind of like it. But at the same time, there's something deeply fucked up about this alignment. Don't you think, chat? Don't you think? So there's something deeply fucked up about it. I'm not really sure. I can't point out exactly. But anyway, so there's the size. Might as well just like split these things in pairs to make it a little bit easier for myself to do it. Yeah, so just a little bit easier for myself. This one is going to be something like void var, and that's levar, and this one is going to be a flag list, by the way, right? So you'll have to allocate your own list then, and this one is going to be var. So now let me void var, var. All right. Okay, so now we need to implement the rest of these functions, chat. Now we need to implement the rest of these functions. I'm thinking how we're going to do that. So let me take a look at the implementation. I think all of these functions are going to be implemented in a similar fashion. Yeah, they all basically get forwarded to the one that works in a specific context, and that specific context is a global context. So we need to just go through all of these things. Macro. I don't want to introduce macros, by the way. I don't want to introduce macros, and I learned that the hard way because sometimes I use these libraries from other languages, and all of these macros are unusable in other languages. So we had a project which is a B compiler, right? So, and I used some of my libraries from Rust. And it was such a pain in the ass. Like some functions were aliases, macro aliases, and I literally couldn't use that aliases from Rust. So, and from that lesson, I realized that like for these libraries, I want to just have functions like for each individual thing in here. So I can use that from a different language through FFI and stuff like that. Through FFI. All right, so what do we have in here? So this is that, yeah. And where is C boolvar? So they all kind of grouped together, actually. They all kind of grouped together. I'm not even sure. So boolvar. All right, so here is the variant for this kind of thing. For this kind of thing, so this is going to be that. And this is the var variant. So this is the var variant. So put the var in here. And this is just a void, right? So this is just a void. And this one has to be var, where we pass var. Okay. So now this one doesn't exist, which means I have to create more variants in here. So yeah. Now I have to repeat that for the context variants as well. Damn. All right, so that feature introduces a lot of new functions, apparently. That introduces a lot of new functions, but maybe that's fine, right? So this is probably what I signed up for. So this is for the context in here, and this is the var. This is the var. This one is also var. This one is also var. So sometimes you just have to grind through. Maybe this is something where an AI would be useful, but I don't know. Sometimes it's just like easier to do this kind of stuff manually. Sometimes just, and it's kind of therapeutic, to be honest. You just go through all of these things and just like copy paste them and just work on them. I don't know. So this one is a var. Emacs magic. I don't think Emacs magic will help that much in here. But I mean, we're using a little bit of Emacs magic for duplicating lines and stuff like that. So I don't know. So this is a list mute and this is a list mute var. Right, so we have forward declarations for all of these things. Okay, so let me see. So this is that function. So I want to find the definition of this thing. Okay, cool. So we now need to have a variant, which is a var variant of this thing. So this is going to be var, and I'm just taking this entire thing. This is var, and yeah. So instead of using value, we have to use the reference now. So this is going to be reference, and I'm just setting the var as that reference, and then the default value is this thing, and I'm actually not returning anything in here, right? Not returning anything here, and it's just like use ref true, just use ref true, and that's it. So flag c boolean var, let me find that. Yes, that's very close to how I do that. Yes, so here is the boolean. Now it's a little bit in a different order, right? It's a little bit in a different order, but maybe that's fine. It's because first comes the default and only then the reference. All right, but doesn't matter. Order in this specific case doesn't really matter. Okay, so let me try to compile the whole thing, and it seems to be working. It seems to be working, seems to be compiling. So which means that now I can actually move all of them to external variables. So I can do n and m. This one is going to be flag var help. All of this thing is var n, and this one is m. So in case of help, it's just that, and we don't really need the name. Let's actually do the printing. So n is going to be equal to lu n, and this one is going to be m. Let's not forget the new lines like so. Okay, so that seems to be working. Then I can do n69, m 420, then do then I can ignore m. It is back to 0. I can unignore m. I can put equals in here. So equals work in here. Ignoring works even with equals. All of that works. And I can put help in here, and it prints the value. And that is with external location. All of that works. All of that actually works. And in here, I think it would be kind of cool to do the following thing. Use a name, right? But supply that name through flag name, right, where you have something like that. So we directly taking the name from a pointer in here. So then I can just do something like that, and as you can see, it in fact works. It correctly gets the name. So now we can even move some of the flags to previous way of storing them. So without the var, just like this. So that will probably not compile, which is understand. No, it did in fact compile, surprisingly. So how do we use m? Yeah, because flag name accepts void star, sadly. So that means now you have to do it like that. And now you have to dereference it like that. And that works. Okay, so we use mixed up way of storing things. So some of the flags are stored within the context of the flag, some of them stored externally, and all of the features work, right? So all of that is working, all of that is working. We just need to implement the rest of the variants, right? So we implemented uint64, right? So then we need to do the size and so on and so forth. Yeah, it's kind of cool to have both of them, because sometimes you want to have these kind of variables, right? Sometimes you want to have internal thing. It's kind of funny because it takes an experienced programmer to really get AI to accomplish any real work. That's why I'm not scared of them taking over anytime soon. Yep. Yep. I already talked about it even back to 2022 or 2021. Right, literally. It's just like, what was the end goal of the, of this AI automation? It's just like to take a manager and now like manager uses AI to write code instead of programmer, but now manager is the programmer. So it's just like, I don't know. So people really misunderstand what is programming. So that the reason why people want to automate programming is because people fundamentally don't understand what it is. Right. They fundamentally don't understand what it is. They think that programmers is the one who's laying the bricks, aka the work, doing the work. Right. So so they think that writing code is like laying bricks, which is fucking crazy. The only person who would think like that is the person who doesn't know what is programming, right? So, and they think they can separate the role. Okay, we have an architect, who decides how things are gonna be built, and then we have these peasants laying the bricks. Right, so we're gonna automate the peasants laying the bricks, and then the architects will just snap the fingers and it's gonna happen. No, the work of the programmer is actually figuring out things. Right, it's not laying bricks. Right, and until like MBAs realize that writing code is not laying bricks, they will try to automate this completely unsuccessfully. Right, so not to say that there are some ways to automate programming, not to say there's some ways to automate programming, but whatever these stupid ass MBAs think it is, ain't it? I'm sorry. So that's not how it works. Writing code is not laying bricks. It is not laying bricks. Writing code is understanding. That's what it is. It is understanding. Laying bricks can and will be automated. Probably. If you lay bricks in a very specific like pattern. So anyways, let's continue. So let's do the rest of the things. uint64 var. So here is that, and we need to create a variant for this thing now. All right, so we need to have a var variant. I wonder if I can automate some of this stuff that I'm doing with macros. Is that feasible, actually? Is that even feasible, actually? Maybe it is. So this is that. Right, because I kind of find myself repeating this stuff over and over again, which means that it is probably automatable. So this is just a ref now. This is ref. I set var to ref and then flag use ref. Use ref var. I just realized that with this use ref, I sound like a React developer. Am I falling into the same trap as the React developers with this use ref shit? But I mean, it's not an API, right? It's an internal thing. No, this is fine. I think I'm not falling into the same trap. All right, so it doesn't fucking compile, Brovsky. So this is because I had to put var in here. All right, so and there is some scheisse in here. So this one is var. Okay, use state, yeah. Okay, so that seems to be working. That seems to be working. Seems to be working. So one thing we can do, I actually want to make it so size tm, and I just do flag size var m. How do we do m? So this is the name and this is that. Okay, let's try to do this kind of thing. And you know what this means, chat? You know what this means? I should be able to put k in here and it multiplies it, but if I put k in here, it will not do that. All right, so because this is not a size, this is just an integer. It's only for the type size, and this thing is working. All right, so we're slowly speeding up the way we are adding support for different types in here, so which is super nice. I really like that. So as of right now, we don't have a flag strvar, right? So, but the way we can do that is we can find the implementation of this thing down there, copy paste this mother flipper, just refactor the signature of this thing into var, call this var, and call the var variant of this thing. So now let's find this thing. Let's find, and it is not implemented yet. Let's find this stuff somewhere here. Copy paste like this. I'm slowly getting a hang of how I want to implement this entire stuff. I really like that. So this is a var, and this is now a ref. So var. Yeah, that's fine. That's totally fine. So this is a ref, and then flag use ref true, and there we go. I think we in fact implement. Fuck you. So we don't have to return anything. That's fine. That's fine, chat. It's fine. So name var. Okay, I figured that. Okay, so everything seems to be working. Now we need to test that shit. Test that shit. So I want to have something like char name, right? Char name, and I should be able to do flag str var, and I provide the name aboba. Value for name, right? So we're gonna put this stuff in here. So now I should be able to do something like name, and then the value is gonna be name, which is gonna be as well, something like that. Okay, let's go. So it's initially null, which is kind of stupid, because it's supposed to be aboba. Something is fucked up with default values, chat. Something is fucked up with default values. We figured it out. We found it. We found out. Okay, so if I do flag parse, where is the flag parse implementation? So it's a flag parse C. Oh, it's a C. Flag parse C. All right. So where do we have the default? I know that the default value is located somewhere in def. How do we even use defs? Aha, that's bizarre, honestly. I don't see def being used. Aha. Well, I mean, it just sets the def. So when I'm referring to this stuff, okay. It's not used anywhere, but what about .def? .def. So the default value is not fucking used anywhere. Excuse me. Did I literally remove it somehow? Or what? I see. I see, chat. I see. Because it's created like this, right? So, and then it's a var. And one of the things I forgot to do is then take that reference, or literally take that var, dereference it, and set the default value to it. That's the thing I need to do for each individual of this variant, is just set the default value, and I completely forgot that. I completely forgot that, chat. I completely forgot that. Oh my god. So now this is probably a very reliable pattern to find each individual function in here. It's pretty reliable, not gonna lie. Okay, so, and in here, what we want to do, we just want to do var default. Next one. Okay. var default. Next one. Okay. var default. Next one. Okay. var default. And that's it. We exhausted all of them. So now it is working, and it is a boba. So assuming const qualifier from point. It's kind of interesting. Why is this const though? Fuck. Why did I make it so the default value is const? Because the internal thing is not const though. Though I don't plan to change it. So so where is the note kappa? Yeah, I won't touch them, I promise. Okay. So I think that's how this particular message came to be. I won't touch. Okay, I won't touch it, I promise, kappa. Yeah, so I'm removing the const, but I promise that I'm not gonna touch it. So alrighty. So that seems to be working, chat. And now I should be able to do name, test, and it is working as well. It's working as well, then I can do something like that. And then it's a help, and yeah, look at that. Look at that. Value for name, default, aboba. So, it's gonna str var, varp? The fuck is this shit? Str varp. Alright, so if I, okay, so that seems to be cool. Need to do the same shit for lists. I still don't fully understand what this const means exactly. Same. I don't understand the code I'm writing as well. Alright, so this thing is not implemented anywhere, so let's just grab this thing. Okay, so let's create a variant which is a var. So void var boom var. Okay, so and in here we're gonna call var, which is var cool. So let's find this thing specifically. Well, I mean, it's this one, but it doesn't exist anywhere. Its implementation doesn't exist anywhere, but this thing does exist here. So we're gonna put it like that. So this one becomes void, and this is var, like this. Oh, and this one is rather interesting, right? So because there's no a notion of a default thing for the list. By the way, like, you guys know what is a list in this specific context, right? So there's a special class of flags which are called lists, right? So, and essentially here it is. So it's when you provide the flag several times, what it does, it doesn't reset the value over and over again, right? So for example, if I have size 69, right? So then I can do size for 20, and it basically picks the last one, right? So we can provide as many as them as you want, and it always picks the last one. But there is a special class of flags which is a list. So what it does, every time you provide an element in here, you actually append that element to the list, so it's collecting them. So it is actually collecting them, so the list like this, and you can then in the code iterate that list. So this is basically what it is. Like a URL params, exactly, like a URL params. It's not like each individual flag resets it, it's actually collecting them. Do you have to always provide list? Well, I mean, it's a really strange question, I don't understand it. Like, I defined a list flag. Or you mean if I define the list flag, like I didn't provide it, so the list is empty. Right, so the list is empty. If I did provide it, and now it contains one element and then two elements and so on and so forth. So I don't understand the question, right? Do you always have to provide it? You don't have to. You don't have to use this library. What is this question? Just don't use this library if you don't like that you have to provide the list. Anyway, so now so what we're gonna do in here, so the listing, we have to do the following thing. So this one is gonna be var. I think they mean list. Jesus Christ, that was difficult to understand. So you mean you don't like the fact that you have to provide it like that and not like this? Is that what you want? Is that what you want? So this is like 69 for 20. How do you know the end of the list though? How do you know the end of the list? So you have to introduce a special flag. I don't know. So you somehow need to know the end of this. Based on dash, that's lame. No, we already use dash dash to say the end of all arguments, so then you can grab the rest of the arguments. So essentially, there is this thing. So here's the rest of the arguments. Here's the rest of the arguments. If you just try to provide a random bullshit, well, it kind of works, right? So, but it just goes into these arguments. I don't know. So, I don't know. Okay, so flag.h, flag.h, flag.h. So what do we have in here? Flag, ref, flag ref, we assign the var in here. Right, so, and then we do flag use ref, which is going to be true. And the default value is not even applicable to the list, by the way. The default values are not applicable to the list. That's fine. Okay. So let me see. Now what we're gonna do? Let's introduce the flag list. What's called access. I want to make it static, so it's sort of like zero initialize. Maybe we can zero initialize it ourselves. So okay, flag list var. So this is access, and that should be it. Honestly, I think. All right, so array of access. So then in here, we need to print it. All right, so it's going to be iterate the whole thing. So it's a print f s equal to that. So flag name access. All right, so flag name access. So after that, less access count plus I. Let's go. So then we print f s access items I. All right, so we need to separate it by a comma. So if I is greater than 0, we just do print f comma with a space, and then print f. Close that. Okay, let's fucking go. Let's rebuild the whole thing. Where is my? Okay, here it is. Okay, pretenf. Okay, so that's very cool. And I put help in here. Okay, so that's pretty cool. I can do access foo, and that edit it in here. That's pretty cool. Then access bar, and that's bar in here. And all of that is an external thing. All of that is an external thing. Okay, that's cool. So all of these external things are apparently working, right? So I'm happy about that. So there's the last thing, and so it's a mutable variant of the flag list. Okay, so listen. So there's a flag list. Where is that flag list? There we go. And there is, which basically items of const chars. And there's a flags list mutable where chars are not constant. So, and there is a, yeah, to do. It was a mistake to make items const in flag list in the first place. In the next major release, get rid of flag list mute and make items mutable in flag list. So it's kind of a hack, but this is because I made a oopsie doopsie. Yeah, so I have to live with my mistakes. Flag list mute. Where is that thing? Let's find it. Okay, so here's the var. This particular thing is not really implemented anywhere, but this thing is. Let's repeat the whole thing. This becomes that void. I'm really happy that I have some sort of a protocol in here that I can just like mindlessly follow, and it kind of works. Right, so then this one does not exist, but this one exists. And just grab that. This is a var, a variant of this thing. Return value is that. Let's put it in here like that. There's a var, flag, blah, blah, blah. And now, what do we have? So ref is just var. And yeah, we also have to just mark flag as use ref true. Okay, so does it work? It doesn't compile because this one has to be a variant of var. Forgot to mark it as var, and that works. So to quickly check if this thing works, let's just change it to mute. So let's just change it to mute. It doesn't compile because this has to be mute, and that still works. Okay, so I think I implemented this variant of flags for all of the types that we support. There was a lot of changes, honestly. There was a lot of changes, but I think it was worth it. I think it was worth it. So what we have to do now, and it's a lot of kind of like a stupid copy-paste work, honestly. It's a lot of copy-paste work. So maybe it would be nice to actually add some of that stuff into the example. Right, for example, help. Let's actually make help a global help variable. So this is going to be this, and this one is flag var help. Okay, so where do we use help in here? So we don't have to make it as a pointer. Yeah, there we go. So it's just one of them. And let's do the compilation. Our compilation process for the example also tries to compile it with C++. So we're trying to make sure that the library also works in C++. Even though I don't have to do that, I still try to do, yeah, so return without expression. Oh yeah, that. So I also try to compile it with pedantic. Damn. Since this function returns void, I can return void out of the function that returns void. But not in pedantic mode, but just generally it kind of makes sense. Alright, so that means we have to get rid of that. So let's fix all of that fucky wackiness, but it's only a warning, right? So it's only a warning, nothing particularly special. And that's a lot of places where I did that thing. It compiles with C++, even with pedantic. C++ 17, pedantic. So it's a perfect C++. Look at it, look at it. Look at that. People accuse me of being the C++ hater. C++ here. But my library supports C++. So you can cry as much as you want. Like, I respect my users. I respect your users. To that cry, I can only say skillish. Skillish. So yeah. I honestly always try to support C++ as much as I can, because you never know in which environment you're gonna end up with, in, where you may not have like a proper C compiler and the only thing you have is C++, and I think the library has to be useful even in that environment. So as much as I want to drop the support for C++, just supporting it a little bit is kind of beneficial for the humanity. So, just saying. Software engineering doesn't care about your feelings towards your favorite languages. That's a lot of function we introduce in here, look at that. And the fact that all of them are unaligned makes it extremely difficult to read, honestly. But it is what it is, and it isn't what it isn't. So, are we ready to make a release? Are we ready to make a release? Oh, I'm fucking releasing. I'm fucking releasing, chat. I'm about to fucking release it. And, oh, actually, yeah, so I did the previous release also today. Okay, so introduce var variants of flag functions. Yeah. So var, so here it is. Var functions variants may break functionality. We are fully aware of that. That's totally fine. So that's the release. So let me review what I've done. Do I want to keep these spaces in here? Is that a good idea to keep these spaces? I'm not quite sure. So maybe What if I also go flag C boolean? What if I grab these things and put them in here? So everything related to boolean, like all of the variants related to booleans, are in here. Is that a good idea? I'm not sure if it's a good idea. So, but I'm not sure if I want to reshuffle things right now. Not sure. Okay, so this is new things. We also add, yeah. Okay, so we probably want to do the following thing. We're going to replace value underscore with just value. So we put underscore for the sake of refactoring. Okay, so we don't have to do that. All right. That's a lot of different places. Okay, cool. Everything seems to be compiling. Okay, so we only edit useref and the ref. In terms of like, maybe I just want to do it like that, right? So because it looks better on the diff useref, and then you have a ref. So flag name, it now uses a specific context, and now we have this very interesting thing where we iterate over the flags, and this particular thing should be unreachable, that's for sure. But is that a good idea? Maybe we could have, yeah, so should we just crash if you didn't provide a valid pointer in here? We could, but is that a good idea? Maybe we could just return null. I think it's a pretty good indication that you just provide a bullshit in here. I think it is, yeah, just like you provided bullshit, you got null, right? So we didn't fucking know what it is. So I think that's fair. So this is the boolean. So for the context and all of that are just like copy paste things. So they're more of a decorators, adapters to different interface, nothing particularly interesting. And here is the actual implementation, right? If you use a ref, you use that. And there's a lot of duplicate code in here. I have a strange feeling that it could have been maybe compressed somehow. It's just like you could say, you could have a function where you provide the flag structure and you can say, give me the pointer. And inside of the structure, whether you use ref, you give one pointer or you give another pointer. So I'm thinking something like that, but I'm not really sure how exactly I want to approach that. Right, because that particular function will return different pointers. That's the thing. It will return different pointers, but maybe it should return void star. It should return void star, and then it's up to you to cast it to a specific type, because you're casting to a specific type anyway, so it's not that different for you. So maybe that function is going to be internal. Do we have internal functions anyway? Yeah, we do. Look at that. So I have this convention that I stole from Sean Barrett, that internal functions have double dash in here. Yeah, so maybe I'm going to introduce another one. So flag, so get ref, probably. So in here, we're going to give you the pointer to the flag structure, right? So here's the flag structure, and that's what we're doing here. Okay, so I'm going to copy paste that, and let me find the implementation of this thing. So that's how we're going to go about this. And inside of, yeah, this one has to return void star. And this one is rather interesting. Is that now, not ignored. So we can take the flag, and if it uses the reference, we return, can you see the scheisse in dismissed? Yeah, we return the reference itself, so flag reference. Otherwise, we return pointer. Oh, and it even just naturally looks better, I think. It even naturally looks better. And then I do, since it's a union, flag value is a union, taking a pointer to any of its members is the same as taking a pointer to itself, right? So because it's a union, so it's totally normal to do it like that. Okay, so if I try to compile the entire thing, so there's something weird like that. So defined but not used. Understandable, totally understandable. So not ignored. Let's actually start with maybe flag boolean, right? So, and the thing I want to do in here is basically, instead of doing this weird contraption, what we can do is flag get ref. Then I do fc flags I take a, do I want to take a pointer to it? So yeah, so I probably want to take a pointer to this entire thing, and it returns me a pointer which I know, since it's, are we back? Chat, are we back? We're back. And this is because I'm using VPN, right? I'm streaming through a VPN. But Zozin, why don't you use blah, 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 blah. Okay, so essentially what I did, chat, is I moved that huge ass condition into this function, and now it's a single statement. It's a single statement, and I can do shit like that. Do you like C? Look at this C code. Look at this C code. Isn't C a beautiful and elegant language? Look at that. It's so fucking readable. I'm gonna fucking come. Holy shit. Why are we still programming this shit language? Can you tell me? Why all of these C killer creations create unusable abominations? Why? Why they're becoming the very thing they swore to destroy? Can anybody fucking tell me? Oh, right, so it compiles, holy shit. Try model to, yeah, should do that. I should probably do that. So, and this is the help, and that seems to be working, so that's kind of cool. I hope I didn't make any mistakes, right? So, because I feel like I might have, So let's actually go through all of the places and maybe, yeah, maybe I'll actually use that function everywhere, because I think it's a good function. Chat, I do believe so. I do believe it's a good function, and it will allow me to compress a lot of things. So essentially now I can just do it like that, and yeah, that gives me a flag list mute. So this is the list, and then I just do flag list append char star list. Honestly, so can I just inline it like that? Is it safe to inline it like that? This is a real question. Is it safe to inline it? So internally, this is a macro. This is DA append macro. And yeah, it is not safe to actually do it like that, because look how many times the list is actually called in this kind of... Oh boy, yeah, so you probably want to put that into a separate variable, that's for sure. So let's not do that. So it has to be list like that. Then we append the argument into that list, and there you go. I compressed the whole thing. So I compressed the whole thing. So yes. So this one is not really mutable, but just a regular list, and this is a const. This is const. Okay. So what about str now? With str it's a little bit easier, because it's kind of similar to boolean, right? So it's just like you're using a different pointer. Nice language, by the way. Nice language. Okay. So int uint64. It's another one. And it's int64 underscore t. Okay, so it's a flag size. So this is a flag size, And it's going to be size t flag size. Okay, so I suppose we compressed all of this stuff now really tightly. And this is, oh fuck, did I make such a fucky wucky? Yeah. So what do we have in here? Invalid conversion void. This is a C++ complaining for downcasting. Spirit my yo, thank you so much. Okay, so let's actually satisfy C++. So satisfy C++. Flag list mutable star. Flag list mutable star. Yo. Okay, so let's take a look at this kind of stuff. Yeah. So I already removed my previous example, so I'm not quite sure how do I want to go about all of this. So let's move maybe some of them to this thing. I need a way to like test both of them, both of these things. Maybe I should create two examples. The first example is using these variants of the flag. Another example uses the other variants of the flags. So I'm not 100% sure. Boolean help. Where is the flag? Equal. Let's put it like that. Var. Okay, so this is just that. Maybe we should have like a boolean 2, right? So this is the second boolean. Okay, boolean flag 2. And in our case, it's going to be actually boolean 2. All right. Maybe we're gonna have them as like separately in here. And this is another one. So, and this one is boolean 2. Yeah. So, and this is a var, obviously. So we have to have size 2. uint64 uint64 2. Fuck me. Okay, so let's rename this one to integer. Alright, so this one is gonna be integer 2. Why is it so difficult? Why naming is so difficult, chat? Can anybody tell me? Why is it always so fucking difficult? Flag list 2 electric boogaloo. Okay. So flag boolean, so flag size 2 size flag 2. Can we have a little bit of an automation, because it's kind of annoying. Yep. Okay, so we get that, which means I can actually do something like this. All of these things are var variants. Let's align them by open parent. Let's then grab all of these things and put them in here, separate them with a comma. Like so. And maybe we can use a little bit more Emacs magic to at least put 2 in front of each of them. Something like that. So that's what's going on. So, but at the same time, I need to manually like readjust them back, if that is even needed in here, but I'm not 100% sure. So there's another interesting thing is that I now need to print each individual flag in here. And one thing I do in here is just like I compute their width, their maximum width. So I'm gonna copy paste this thing in here, and now I am using 2 in here. So I have to replace uint64 with an integer in this specific place. So 7 align if So that's what we have in here. That's pretty cool. So, and this is the list, and I'm thinking, so this is just prints list. This just prints list. Can I factor it out to something? I should probably do that. So it can be print list, and essentially what I have is maybe something like const char items, bunch of items, actually several of them, and count. So in effectively what we do, we print open bracket, then closed bracket, maybe with a new line. We're iterating all of them, so it's going to be something like that. Count plus I, print this as items I. Let's separate them. If I is greater than 0, we are printing the assets, well, I mean the comma with the space. So this is a print list. So that means in here we can do print list. The items is list items and list count. Okay, so that gets rid of that. And here we're printing another list. So because we're going to be duplicating this kind of stuff, we're going to be duplicating. So print list argv argc, and let's remove that. Okay, so this is just the arguments, but on top of that, we need to have second variants of them. So this is a flag name, so that means this is 2, right? This is 2. This also becomes 2, and this also becomes 2. And this one is integer, by the way. So I need to also do the replacement for uint64 and integer here, like so. It's an integer 2 and string 2. And by the way, without any dereferencing. Okay, so I have an example which checks both variants of the flags with an internal storage and an external storage. This is a good name I just came up with. External storage flags and internal storage flags, chat. This is a cool name. Having a good name is always good. It is always fucking good. Anyways, so let me see. If I try to compile this entire thing, let's go to the compilation errors. So what do we have? Flag, yeah, so you have to take them by pointers. That is in fact understandable. Let's go through other compilation errors. So you don't like, this has to be just star, like this. What else do we want? Flag, oh yeah, all of these things have to be now pointers. Like this. Oh, and now we have to realign. Oh! Fucking Emacs. Okay, so align if cool. What else do we have? Boolean, and all of these things have to be pointers. All right, so what else do we have in here? This is not a pointer. This is just a value. Okay, what else do we have in here? argv point is incompatible. So you have a char star star, but we expect const char star, and it just doesn't work like that. Fuck you. Fuck you. It's const is annoying. Const is fucking annoying. Anyway, so here's the C, and there's a lot of things in here. Oh, and by the way, we have to name them differently as well. So this becomes 2, 2, 2, 2, 2. All right, so let's recompile. All right, so here's the bunch of flags that we have in here. Damn, okay, so, and it always, this is sus. Why does it return true? I think I know. So because help suddenly became a pointer. Let's not make it a pointer. Okay, so here are all of the possible flags. Now I should be able to do Boolean. So this is the first Boolean, it is true. Second Boolean is not true, but now I can do the second Boolean as well. Okay, that's pretty cool. What about integer 2, 69? Aha! The fuck is this shit? I think I know. Got you. I think I know. It's not 69 though. Flag.h. Flag.h and So let's go through all of them because I copy pasted the shit chats. Look at that. I copy pasted the shit. Yeah. Has to be arg. So okay, so that's understandable. So this is size and it is arg. What is this? uin64 has to be. Does it has to be arg? Okay, so let's go through the review. Through the review. So it used to be a result, now it's arg. Okay, so let's keep it result then. So this is also results. Okay. It used to be arg, it is arg. This is because it is a string. Cool. So this is true, which is understandable. Now we're appending. So we were appending to mutable list. Now it is that. All right, so everything seems to be working. So now, if I recompile the whole thing, it is 69. So let's actually test all of them. Let's test all of them. So you have boolean, boolean2, they're set, and let's set integer to 69 as well. Might as well even put that to some sort of a run sh, to make it a little bit more readable for ourselves. Maybe set xe, right, so because I want to be having this kind of stuff. All right, so this is that, and let's just run sh. Did I make it executable? So run sh, here it is. Cool. So we also have to set the size. So size is 420. Size. So this is the first size, but the second size is 0. Let's do size to 420. Both of them are 420. Both of them are 420. So what about the string? str hello. Just str hello. So str first, str is hello, the second str is not, str to hello. Hello. Both of them are hello. So now we have lists. Okay, so this is going to be list foo bar list buzz. All right. So the first one has foo bar buzz. That's understandable. That's understandable. Now we want to do the second list. Okay, so this is going to be list 2. All right, so all of that is fine. And after that, we probably want to put something like this, and we can say test, maybe hello world test. So this is the rest of the arguments. Okay, so the difference between the first set of flags and the second set of flags is that the first one is uses internal storage, the second one uses external storage. So we tested all of them. So now we have external storage. Pretty cool, and it works reliably. So it's kind of a big feature, honestly, if you think about it. Rather big. I had to make this amount of changes to implement it. But it works, and it's cool. All right, I think I'm more or less ready to do the commit. I'm more or less ready to do the commit. So let's remove that stuff. None of that is needed. So we updated the example. So in here, yeah. So let me copy paste. And let's do the release. Release version 1.6.0, which is introduce var variants of flag functions. Okay, so I'm gonna push that right into the repo. How about that? How about that, chat? But you didn't expect that to happen. So it is released. Wait a fucking second. What the fuck is this shit? Did I git clone an HTTP version of a freaking chat? The fuck is this shit? Okay, so can I configure my origin? So I'm gonna set URL, which is gonna be git@github.com, which is tsoding flag.h.git. And if I push that into the repo, did I first try the freaking, yeah, so I actually first tried it. So this entire thing is in fact released now. So flag.h. About that, this guy cloned the HTTP lol. Yeah, I know. I know, very funny, very funny. So yeah, we have a thing that I needed for quite some time already. Accidentally cloning via HTTPS is marginally less painful than stepping on a Lego. Well, I mean, yeah, true. That is kind of true. That is kind of true. So we're getting even closer to how Go library works. We're getting even closer to that. How do you plan to incorporate it into the game? It's already incorporated into the game. I already use it. It's just like I want to have external storage for variables because it's a little bit convenient for what I'm doing in there. So, because I have a bunch of global variables and I want to just point to that global variables and say like store the flag values there. So it already works like that. There is just like I'm not using flag.h for that, and I'm not using flag.h for that because it was not supporting that. So yeah, nothing particularly special. It's just kind of like a chore work. So yeah, I guess that's it for today. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azusa. I love you. Mwah.